Welcome once again to Isifeedublog. Subscribe, make sure you click on the notification bell. You can share it too. Now, in this particular video, we are going to be treating the Neco physics practical, the likely question that is going to come out from the thing they gave us. I was able to draft out this particular question. So you should be expecting something like this in the hall. Now I'm going to go through the question, read the question. The most important thing, before you make use of anything I'm going to teach you here, make sure you go through the question and confirm that everything is still the same. Now, as I'm reading the question, it will appear in the screen as you are seeing. Okay, now let's quickly venture into this. Now, the question, this is the diagram. You always see the diagram first. I will explain the diagram later. Use the diagram, then you now see the question under it. Now, the question goes like this. It may not be exactly my statement, but it's still saying the same thing. And the question goes, study the diagrams above and use them as a guide and carry out the following instructions. So we are making use of this as a guide and carry out the following what? Instructions. Okay. Now you are provided with a G clamp, and this is a G clamp. This is what you call a G clamp. A mass hanger. This is a mass hanger. Or you can use a thread to replace a mass hanger. Use it to hang the mass. Now we have different masses, 50 kg each, which is this. You have different masses. All these things will be provided for you in the hall. 2 meter rule. We have meter rule 1 and meter rule 2. A pointer and a retor stand. So this is the retor stand. This is the pointer. Okay, and let's see what the practical is. It says, suspend. Okay, first of all, they say, measure and record hinge knot. Measure and record hinge knot when no mass is hung on it. So, first thing we do is to measure and record hinge knot. This is hinge knot from here to here when no mass is hung on this meter rule. So, that's the first thing. Now, the next question says, suspend the mass hanger M equal to 50.0 grams on the 5 cm mark of the meter rule using an inextensible thread, or they can say using the mass hanger. So what they are trying to say is, the first practical, use your 50 grams mass, hang it exactly at 5 cm mark. Now they may change it in the hall. Instead of 5 cm, they may say 10 cm. It does not change anything. So what that simply means is, use your thread and trace 5 cm from 0. You are counting 5 cm. Make sure you hang it here. Now this 5 cm will remain the same. You don't shift it till you finish your whole practical. Once you measure your 5 cm and hang your thread on it with your mass, leave that mass there. Leave the thread there till you finish the practical. You don't change it. So read very carefully. If they say 5 cm or 10 cm, it will not change the result of the practicals. Okay, let's continue. The answer, determine the pointer reading on the meter rule. Determine the pointer reading on the meter rule. What does that mean? Once, initially, hinge knot is when you have no mass on it. So if you hang mass now, this was here before. So once you hang mass 50 kg, this meter rule will bend. So as it is bending, the pointer pin that is here will also bend. So from here now, it will come down a little bit, pointing at a particular height from the ruler. So what do you do? If it was here before, so when it shifts and bends this way, you read. So from here to any point, it is ending, after bending, is what you call H1. So you can read H1 by saying from here to here, that is H1, or you can say from here to here. Or if you now say from here to here, that means you subtract away from what? H0. So you remove H0 away from here to here, and you get your H1. But the easiest thing to do is to read from here to here. But if that will confuse you, there is no problem. Once this thing bends, let's assume that from here to here, what you got H0 is 10 cm. as you have recorded. And once this thing bends, this ruler bends, this pointer will bend too, and your reading on the meter is, let's say, 17.2 cm. So that means that from here to this point is giving us 70.2 cm. While from here to this point is 10 cm. This is static. 10 cm is static. So for you to get H1 will simply be what? Very simple. H1 will now be 17.2 minus 10. As easy as that. So H1 will now give you 17, the whole of this distance, minus, if you remove here, you get H1. So it's as easy as that. Now, that is the first thing. Now we continue. And then I say, record H1. That is what I just showed you. Record H1. And then I say, determine the pointer reading when the mass is completely immersed in water. And record the height as H2. So that is the second part. You are using the same setup, but the difference is now, this one has no water in it. So once you, after doing this, you record your H1 and keep, then you bring your beaker or anything you are using, water. Remember, they say completely immersed. So this mass now, make sure it's not partially immersed. Make sure the whole of this mass is inside the water and is not touching the bottom of the beaker. So once you put it, that is what we have here. So once you put it again, you find out that this pointer will still bend again. Now because of upthrust in this particular water that is affecting the mass, the upthrust will make this height definitely will be smaller than this. H2 will be smaller than this because upthrust in water is affecting this mass, so it will be acting upwards. So this practical is based on what? Archimedes' principle and the principle of flotation. So make sure, go and learn how to solve questions and how to state the Archimedes principle. So the same way you calculated this, H1, is the same way you are going to calculate H2. So how do you calculate H2? Once this comes down a little bit, your H2 will be anything you get. Let's say what we now got now is 17.0. Remember, your H2 will always be smaller than H1. So have H2, then H0 will be minus 10. So H2 will be this minus 10. It's as easy as that. But if you can read directly from here to this point, from your meter, if you are good, it's still the same thing. Instead of doing the whole of this minus H0, you can just say, if here is 10, and you got to this point, what is the distance from here to here? It's still the same thing, so it will still give you the same answer. So that is what this practical is all about. So we continue. So then I'll say, evaluate V, H1 minus H2. Evaluate V, H1 minus H2. So how many columns do we have now? We have a column for M, which is the mass. We have a column for H1 in cm, that is 2 columns now. We have a column for H2 in cm, that is 3 columns. Then we have a column for what? V, which is H1 minus H2, also in cm. So in this particular practicals, what we have that we form our composite table is 4 columns with the correct unit and the decimal places. So after explaining this, I've already done the practicals for you. We are going to show the outcome and how the table will look like. Okay, then I'll say evaluate V equal to this. The next thing said, repeat the procedure with the object of mass. The object of mass is M equals 100 grams, 150 grams, 200 grams, and 250 grams. So we have extra 4 procedures to carry out. So the initial one is 50 grams. The next one, repeat the same practical, add extra 50 to this. This becomes what? 100. So you check also what the height will give you and get the H1 like we did it for 50. Next thing you do, carry water, put it inside the water in the beaker, and also measure H2. You add another extra mass, making it 150, you repeat exactly the same thing. So in each case, we are recording what? V equals H1 minus H2. Now the question, they say tabulate your readings. I've told you the table of values, that is where they say tabulate everything you got from this particular practical. So the table of values will be 4 columns. We have M, like I said before, H1, H2, then V. So we continue. The next question says plot a graph of M on the vertical axis and V on the horizontal axis. Next question says, so we are going to do that when we, after the practicals and we see our table of values. I've done the practicals already. So we are going to see the table of values, see how the graph looks like. Now the next thing here, they say, determine the slope S of the graph. State 2 precautions taken to ensure accurate results. So these ones are not the slope is not a problem, precautions is not a problem. So always remember, this question is based on Archimedes' principle. Because of this, so please go and learn how to state Archimedes' principle. It's very, very easy. And also the principle of flotation. If you watch the screen, there is a follow-up question that comes up in that. We are going to solve the follow-up questions and you learn how to solve it too. Okay, let's quickly go over to the table and see how the table will look like. So this is how the table will look like if you are asked to record H0. So if you are told to record H0, always know that this is a constant and every constant must be written on top of your table. Note that every constant must be written on top of your table. They may not use this word H. Okay, Neco may decide to call it X. It doesn't matter. So they can call this X1, X2. They can call it XB, XA. It doesn't matter. The most important thing is the same procedure. So the letter does not matter. Just know how to do that. And if they ask you record X0, so that is this. So we have gotten now, done the practical. This is what we have. H0 is equal to, we made H0 to be in 9.50 cm. Another person may decide after reading the H0 may be 15 point something. Somebody H0 may even be 50 point something. It does not matter. So what matters, but the problem is if your H0 changes, the reading, everything here changes. It's as easy as that. So if your H0 changes, the reading here changes. So, but if you are making use of my own and the whole, this is exactly what you are going to make use of. Don't stress yourself anymore. Okay, so how do we get V? This 3.10 minus, as you can see, 2.80, we give you this. We have 6.30 minus 5.6, we give you this, and so on and so forth. So how we got H1, I've already explained it during when I was showing the practicals. Now, the next thing we are told to do here is simply to plot M on the vertical axis against V on the horizontal axis. So that is what we have in our graph now. So if you look at the graph closely, you can see that M with its unit, is on the what? Vertical axis. Always remember, this is what you call marking of axis. M here, then we have V on the horizontal axis with its unit also in cm. If you miss the units when you are marking your axis, you have lost marks. So be very, very careful. Now, plotting this against this, what is the perfect scale we used? We used 2 cm to represent 40 units. 2 cm to represent 40 units on the what? M axis. So we have 40, 80, 120, 160, and so on and so forth. So now the next thing we have here is on the horizontal axis, we have 2 cm to represent 0.4. Hope you can see that. 2 cm to represent 0.4 units. So we have 0.4, 0.8, 1.2, 1.6, 2.0, 2.4, 2.8, and so on and so forth. Now, after the plotting, Now what do we have? If you plot correctly, I don't know how you were taught how to plot graph, but if you can plot correctly, this is what you are going to have. So our line of best fits, you can see this entered the line, this also entered, this entered, and this entered. So we have 4 points entering our straight line. The only one that fell out is this. So this is the perfect line of best fit. If you have any question concerning how to plot this particular graph, please drop it in the comment section before you enter the hall. I will address that. Okay, now let's move over to slope. Let's move over to the slope. Now we are told to determine the slope S of the graph. So we have slope S. What is slope? As you can see, change in M. Change in M divided by change in V. So what does that mean? M2 minus M1 divided by V2 minus V1. So we are going to read it now and see how that works. M2. Now, first of all, before we read this, how do you calculate slope? Your slope must not be exactly like mine. How do you calculate slope? Find a place, always make sure the rule says that your slope must be 3/4 of your graph. That is the marking scheme. 3/4 of your graph. So you don't need to give Neco a small slope. That is, as you can see, my own is very large. So always extend your line so that you can pick a large slope. So slope is a tangent coming from a right angle triangle. So what you do is, as you draw this line, go to the upper side, look for where this straight line cuts these small boxes into 2 equal parts, or into 2. So I found out one here, so I used here. You come down and do the same. Find where this straight line cuts this small box into 2. I have here and here. So I will use this point. Make sure it is very big. I will use this point and form a right angled triangle. Now how do we read this? It's easy. M2 is always bigger than M1, as you can see. So M2 is the tip of this right angle triangle here. The tip here. So we trace it up to this point. So if we trace this line to this point, let's read and see what it will give us. Now how do you read this? So I will show you an easier way of reading this graph, or any graph. Once you have picked a particular scale that is very perfect to draw a graph, what you need to do for plotting and also from deduction is knowing the value of one line. For instance now, these are the scales we picked remember, for M we picked 2 cm to represent 40 units. Now if you want to know the value of one line, one single line, you will count. Remember, if you count these tiny lines, 1, 2, 3, 4, 5, before you reach 40, it will give you 10 lines. So what does that mean? It means that 10 lines is equal to 40. But your interest is the value of one single line. So if 10 lines is equal to 40, what will one line give us? We can call it x. If you cross multiply, you find out that one line will be 40 divided by 10, which is 4. So the value of one line here is 4. Very easy. Now, if I want to deduce something away from this graph, look at what I will do. Since I now know the number of one line to be 4, I'll be counting in lines. What do I mean by that? From here to here will give me 10 lines. From here to here is 20 lines. From here to here is 30 lines. From here to here, 40 lines. From here to here, 50. Are you seeing it now? So let's say 50 now times 40. That will give me what? 200. That is the value of 50 lines. And that is what we have here. It's as easy as that. So if you do from here to here, which is 10, you say 10 times 4. That will give you 40. If you say from here to here, which is 20 lines, 20 times the value of one line, which is 4, that will give you what? 80. So if I want to read what this is here, I will just count. This is 10, 20, 30, 40, 50, 60. I have 60. 65, 66, 67, 68, 69. So this is in 69. So what is the equivalent of 69 in this particular axis? I will simply say what? 69 lines times 4. As easy as that. 69 lines times 4. And when we multiply that, what do we have? We have that M2 is 276 minus 69 times 4 will give us what? 276. Then we come down here and also trace this to M axis to get our M1. The tip of here, remember, use this tip to get M2, then use this tip, trace it, and get what? M1. So let's count how many lines will give us this. So we have from here to here 10, 15, 16 lines. So from my own slope, it is giving me 16 lines. So the question now is, what is the equivalent of 16 lines in this? So that we can get the mass. We have 16 times 4. Now 16 times 4 will give us 64. So this is 64. Remember, slope, the values you are getting for M2 and M1 will never be the same if you change the slope. So I am getting these readings according to my own what? Right angle. If I lower this right angle, I hope you know these values changes. So the most important thing you need to know here is how to read it, the way I'm reading it. So that anything you are making use of, you can replot this graph by yourself. Choose another different right angle. I've told you how to choose that. Go up here, pick where it cuts the small into two, the small box. Come here and pick, form a perfect right angle triangle. Then apply this thing I'm doing. Remember, the value of one line is 4. So once you get the number of lines that is equivalent to anything you have deduced, multiply by that 4, you get the original values. Okay, so let's go over to V axis. Now let's go over quickly to V axis. Now, just like we did in M axis, what did we do? We said if you watch your V axis, 2 cm is representing 0.4. So we are adding 0.4. So what that means is, since it is 2 cm, that means 10 lines is representing 0.4. So one line will be what? So one line will simply be what? 0.4 divided by 10. And that will give us 0.04. 0.04. So the value of one single line in V axis is 0.04. So that is what we are going to use to be multiplying the number of lines. So let's quickly get V2. V2 is bigger as we are going like this. If we are going like this, this is bigger than this side. So we are getting V2, tracing this line now down to V axis. Remember, for M, we are tracing in M axis. So we are tracing this down to V axis. So if we trace this down, this is what we have. So let's count. From here to here is 10, 20, 30, 40, 50. We now count 51, 52, 53. So what I have here is 53 lines. So I will simply say 53 lines times 0.04. I don't know where you're getting my point now. So we have times 0.04. That will give us the value of one single line. Sorry, the original value on the V axis. So let's do that and see. 53 times 0.04. I'm getting 2.12. So if you're smart enough, you find out that this is true. 2.12 because it is exceeding 2.0 and it's between what? 2.0 and 2.4. You can see that. So this value now, if you trace it down, is 2.12. So we have minus. We go back to this. This one, we don't have any problem already. If you trace it down, it's already in 0.4. So no stress, just trace down. What you have is 0.4. So we have 0.4. This is, we're almost done. Use your calculator and finish up this. So our slope S becomes 276 minus 64. This will give us 212 divided by 2.12 minus 0.4, 2.12 minus 0.4, that is giving us 1.72. 1.72. So let's divide 212 divided by 1.72. So what we have as slope is 123.26. Does it have a unit? That's the question. Yes. Why? This is measured in grams. Why this is measured in cm? So this is per cm. Per cm. So the unit of this slope is gram per cm. So this is how to calculate your slope. If you are asked to get the intercept, in case you are asked to get the intercept on the vertical axis, that is this, you can read it. Just count how many lines. Anything you get, multiply it by 4. As easy as that. Count how many lines here. Anything you get, multiply by 4. But in this particular question, I was able to craft out. There's nothing like intercept. But in case you enter the hole, you see intercept on the vertical axis, which is M axis. Just count how many lines you have here and multiply by 4. That is the intercept. So count how many lines you have here for the intercept and multiply it by 4. So that is how to do that. So this is how the practical is all about. So let's quickly go to the sub-questions that come under it. If there is any deduction, we are going to see. We carry on from there. So that is all we need to know about the graph and the slope for now, for these mechanics. Okay, what we have here is the follow-up questions. It may not be exactly this, but always expect a follow-up question, no matter what the practical will be. Even in the next practical, there will also be a follow-up question. So let's read and solve this question. And the question says, a piece of brass of mass 50.0 grams is hung on a spring balance from a rigid support and completely immersed in kerosene. So the fluid here is kerosene of density, this 8.0 times 10 raised power 2 kilogram per meter square, kilogram per meter cube. Determine the reading on the spring balance. So any reading we are getting from the spring balance is actually what? The mass of the what? Kerosene. Once it is, so let's see what that will give us. So, okay, this is how to solve this particular question now. Now, if we look closely, we have the mass of the brass, and we have the density of the brass. And we know that mass is equal to density times what? Volume. So let's get the volume of this brass. So the volume of the brass, VB, is equal to mass of the brass divided by density of the brass. As easy as that. Now, but we know that from the principle of Archimedes, or we say Archimedes principle, that the volume of this object is equal to the volume of the liquid displaced. So if that is the case, that means that the volume for the both of them are equal. Therefore, I can simply say that this is equal to the mass of kerosene divided by the density of what? Kerosene. Remember, mass over volume is volume. Sorry, mass over density is volume. So, because this is constant, this is equal to whatever that is there. And let's see what we are going to have. Okay, so we are making use of this formula right now. We are making use of this. So let's write out the parameter. The mass of brass is 50.0 grams, which we need to convert to kg because of the unit of the density by dividing by 1000. So this will give us 0.05 kg. Now we have the densities. So I'm going to clean here now. The density of brass is in bracket as 8 times 10 raised power minus 3 kilogram per meter cube. Then the last but not the least is that of kerosene. So density of kerosene is 8 times 10 raised to power 2 kilogram per meter cube. So applying this, I don't think we have an issue now. So we are making use of m sub b divided by rho sub b is equal to m sub k divided by rho sub k. Our interest is the mass on the spring, which is what will be the mass when you submerge in water. So that is what we are looking for. Sorry, when we submerge in kerosene, not water. So we have that mk, if you make it the subject, is equal to mb times rho sub k divided by rho sub what? B. So this is 0.05 times this young man is 8 times 10 raised to power 2 divided by this is giving us 8 times 10 raised to power 3. So 8 can cancel. If this goes up, what we have is if this goes up, what we have is 5 times 10 raised to power minus 2. This will give us times 10 raised to power minus 1. So what we have is 5 times 10 raised to power minus 3 grams. So this is the mass you are going to see on your spring. Now, if they want you to convert to force, that is to Newton, what you need to do is simply, that is the essence of the G in bracket. So what you just need to do is you simply do what? 5 times 10 raised to power, just multiply this by 10. So since we have G in bracket, that means they want us to have our answer in Newton. And once we do that, what we have is 0.05 Newton. So this is the reading on the spring balance. Okay, if you have any question concerning the first practical in the hall, which is your magnets, anything you don't understand, drop it in the comment section. Always remember to subscribe, click on the notification bell so that you can get the next practical 2. We are going to meet in the next video.